So, hello everyone, and welcome to this uh, online session that we conduct every weekend. Ask AuxEn Anything. And as you know, this is an online platform where civil structural engineers can interact with us and where they can ask their queries or doubts or difficulties that they may have related to any project that they are doing or a steel RCC concept or construction and site issues. So, this is the 25th such session that we are conducting, and straight away we will start with the questions that have been asked. So first I'll take the questions that have been asked on the Google form, then we will go to the questions on email, and then we will take the questions from live chat. Okay, so let's start, and straight away we will continue from where we had left in the last session. So engineer Pritesh Jain, he is a working professional and he is joining us from Pune. So he's saying, okay, I think what I will do is I'll just share the OneNote. Okay. I hope this is visible. So Mr. Pritesh is asking from Pune, and I'll just paste his question first. So basement G plus 20 story, and so I think he has two structures, G plus 20 story structure and a small utility structure, G plus 4, both connected at a podium level. So he's saying that he has a 20-story structure like this. Okay. And maybe it has some basement. And then he has a 4-story structure also like this. I think that does not have a basement. And they are connected with a common podium. So they are connected, let's say, through this common maybe podium slab. Now he is saying how to provide diaphragm and time period calculation for both structures. So my suggestion in this case will be, because these are so different, so dissimilar structures, connecting them together by one diaphragm, I think is not does not make good sense. So my suggestion here would be that don't connect these two structures with a common diaphragm. Common diaphragm means don't assume them or don't have them connected by a common slab element like this. So don't connect these two structures with a common slab element. It is better because of their because of so much dissimilarity in them. It is better that you disconnect them. So I will always suggest you to disconnect it. So let this be an individual structure and let this be another individual structure. So there is no connection whatsoever. That means you can provide a joint over here, a gap can be provided, and that gap can be worked out on the basis of the expected deformations under seismic loads multiplied by the R factor. So you can work that seismic gap. So provide that gap, have them as dissimilar, and once you do that, time period calculation is straightforward. So then for this structure you calculate the time period, for this structure you calculate the time period separately. In fact, because you have now disjointed it, no need to model them also in one model. You can have them made into separate ETABS models also. Okay, or maybe for raft purposes, because your raft will be common, maybe you do a complete model but have a seismic gap. So you will have to prepare then multiple models. These things I have explained in earlier sessions where we have taken these questions, that if there are multiple superstructures on a common substructure, what to do. You could refer those episodes where we have done this discussion. So short answer here is don't have them connected at diaphragm level, disconnect them, and treat them as two independent structures. Okay, so this was engineer Pritesh Jain with his question. Next question is from engineer Rajesh. He's joining us from Bengaluru. He is also a working professional. So his question is, in seismic analysis, and design, why we should not consider basement wall in analysis and design to take care of base shear? No, who told you not to consider? Who told you not to consider? There are specific conditions under which your code says not to consider. So your code is saying you like this, that let's say if you had a structure system in this manner, okay. Now what's happening over here, that this is your ground level, this is your ground level, okay, and then you have a basement wall over here, and then you have a basement wall over here now, and you have a raft at the bottom. Now what will happen under the effects of lateral loads? What will happen under the effects of lateral loads, that this lateral load will be resisted by this slab over here, okay, and a counterbalancing action will be created by the basement walls in this case. So if that is your situation, then your code says that basement walls can be included. Basement walls can or should be included or can be included in resisting the base shear. But if you have such a situation, let's say where you have this building and this has its own basement wall and a raft, but then that's it, and let's say it's a standalone basement wall, your ground level is over here, okay, and maybe some retaining wall over here which is not connected directly with this basement wall. So this is your basement wall, this is your retaining wall, let's say it's not connected with any horizontal element. Now in this case, your basement wall is not able to provide resistance to your base shear because there is no connecting podium. So because there is no connecting podium or no connecting horizontal slab, whatever this basement wall will provide resistance will be as per the normal course in which it provides your resistance because of lateral loads. So it will still take tension compression couple, it will still take moments, it will still resist those moments, it will still resist the shear force in the form of tension compression couple. But then this action, which I call it as the backstay action, that will not happen over here, okay. So this action we call it as the backstay, where a horizontal element like a ground slab or a podium slab, when it is connected to basement walls, or even if it's not connected to basement walls, it helps you to resist the seismic base shear and seismic overturning moments. In this case, that backstay effect will not take place, but still the basement walls will resist the seismic base shears and seismic overturning moments. So this statement that you have made, why we should not consider basement walls in analysis and design to take care of base shear, I think this statement is an incorrect statement that you have made. We do consider basement walls effective in taking care of base shear. You must be getting confused with the time period calculation. So for time period calculation, your code says under which condition you need to take heights. So in such a condition, your code says that you take this height for time period calculation. In this condition, because it's unconnected with any horizontal system, you take the full height for time period calculation. So for time period calculation, your code puts this thing, but your statement that for base shear, why basement walls will not take, it's improper statement. We do consider the effect of basement walls or uh, underground walls in resisting base shears, okay, and overturning movements also, right. So this was his question. Now uh, engineer Ketan Mahajan, he is joining us from Jalgaon, Maharashtra, and he's asking, please share some insights related to, so last session also he had put one question for load bearing masonry walls. Now he's asking, please share some insights related to structural audit of existing masonry structure. I hope you can see this. The screen is visible, right? Yeah. Okay. So please share some insights related to structural audit of existing masonry structures. Which tests should be conducted? Codes to follow. So I am not quite aware of the codes to follow. But when it comes to audit of existing masonry structure, and assuming it's a load bearing structure that you're talking about, so if it's a case of load bearing structure, the most important action in a load bearing masonry structure is what? Tell me, what is the most important action in case of a load bearing masonry structure? Which action is the most critical? Tension, compression, bending, shear? Which action is most critical? So, the most critical action when it comes to a load bearing masonry structure would be compression. Yeah. So, compression or bearing. So, if you have to do a test, you have to somehow ensure that the compression test or the compression capacity of your load bearing wall is intact, it is proper. So for that, to check the load bearing capacity, I don't think you can, or I don't see any possibility of cutting a core from brick sample, right? If you cut a core from brick sample, it will not, it's not a concrete that you cut a core and you take it to lab and test it over there. That won't be possible. So cutting cores won't be possible. But what you can do, what can you do? So you can take out some samples and take it to your lab and test it for compression. So you take a sample, let's say take a brick and bring it to lab and test it for compression. Okay, so test it for compression. So how much compression it can resist, you test that. So because it's a load bearing structure, its ability to resist compression is the most important ability. So you check it for compression, plus the mortar should be checked. Okay, so there are some mortar tests. So the mortar between the bricks, that should be checked. Okay, you should see if there are any signs of deterioration in the mortar, if there are any chemical or any other physical degradations in the mortar, that you should check. Although I don't know the tests for it, but common sense tells me that mortar should also be checked. You need to check the bricks. So these will be sort of some lab tests you can follow or you can conduct. Although I'm not aware of the code numbers, there must be some codes, Indian standard, but I don't know. Other than this, in audit, you could do a visual inspection. Okay, you could see for presence of any cracks, especially any diagonal cracks or any cracks which inform you about a possible settlement or for a possible shear type of failures or uneven settlements. So you should check for cracks. You should check for verticality of the wall, because most of the times in these masonry walls, what might happen that they can go out of plumb, and because they go out of plumb, because their verticality is affected, their load bearing capacity also gets affected. So these are all visual inspections that you have to do. So checking for cracks, checking for their verticality, I think these are some additional things that you could do on site. Mr. Ketan is adding over here rebound hammer. I don't see how rebound hammer will help you, because anyway rebound hammer is more of a empirical testing rather than any uh, rather than a test which is related with any accurate results, I would say. So rebound hammer is more of a empirical testing. Exact testing is taking a sample or taking a brick with you. You will not be able to take a sample, as I just told you. Uh, Cutting cores in brickwork will not be possible. Your core will not remain intact. So take a brick sample, take a brick out of your load bearing wall, and then bring it to lab and test it for compression. Rebound hammer, I don't see how it will help you. Okay. And then test for mortar also, as I told you, and do some visual inspections. So I think these are some of the suggestions I can make after reading your question. Although I am not aware of the code numbers, neither I have done these types of audits myself, but this is just as per the common sense that I'm telling you. Okay. Maybe you could get in touch with some uh, lab, and then they might be able to suggest you any further information. Okay. Right. Next question is from, who is this? Engineer Dinesh. He's a working professional, and what he is asking, when RC structure dimension exceeds 45 meters, usually expansion joint will be provided. Some of the consultants provide expansion or expansion strip or shrinkage strip or pole strip instead of expansion joint. Detailing of slab reinforcement for expansion strip is done by curtailing the top reinforcement and providing extra reinforcement and bending the reinforcement in plan. I couldn't get clear idea on this strip. Kindly explain where to locate and how to detail such shrinkage strip. So see, shrinkage strips you could provide where shrinkage strips can be provided where number one, as you just said, that you want to relieve. So it's sort of a structural fuse where you want to relieve temperature stresses. Okay. Or in fact, you could provide so we will not call it shrinkage strip. In that case, we will call it as a pore strip. So you could have a pore strip at a location where differential settlement was a problem, and you wanted to avoid that also. So in such cases also, you could have a pore strip provided. Mr. Vinay RB is adding that rebound hammer is only for concrete structures. No, but you could calibrate the readings of rebound hammer even for a masonry structure. You could calibrate those results. Let's say you start using rebound hammer for a load bearing masonry structure also. So what you could do is that you could do the rebound hammer, get the values, then take the brick sample, bring it to lab, do a destructive testing over there, and then try to form certain correlation between the rebound hammer values and the values that you are getting from compression results. So such type of calibration can be done for brick samples also in rebound hammer. But overall, rebound hammer is not a very good test. Rebound hammer is not a good test even for concrete. All right. Rebound hammer is just a test for lay persons. It's a good test to conduct. But for technical people like us, I don't see rebound hammer being a useful test. Okay. So even for concrete, I don't recommend using rebound hammers. Right. Okay. So coming back to the question asked by Engineer Dinesh. So where do we provide pore strips or shrinkage strips? Wherever you want to relieve the stresses. Those stresses may be due to excessive temperature related stresses because of long lengths of your structure, or where you have a possibility of differential settlement, and over there you want to uh, relieve your slab of differential settlements. There also you could provide these types of pore strips. So he's saying detailing of slab and reinforcement for expansion strip is done by curtailing the top reinforcement. Yeah, so I think why they are curtailing the top reinforcement, because they don't want continuity to be formed between the two slab elements and the pore strip. So because you want to have a discontinuity, that's why uh, to have a discontinuity at the junction, they are curtailing the top reinforcement. Okay. This statement I have not understood, and providing extra reinforcement and bending the reinforcement plan. I didn't understand this. In my opinion, you cannot have a specific standard detail for all kinds of shrinkage strips or pore strips. It will depend on its span, it will depend on its location, it will depend on the forces, the loads that it has to resist. So it will depend on all those things. So generalizing the detailing practice for a shrinkage strip or pore strip, I don't think we should do that. What we should instead understand is that wherever you want to have a structural fuse or wherever you want to relieve stresses, you could have this pore strip or shrinkage strip provided. So even in your industrial floorings, even in your RCC pavements, you do this kind of a thing, right? Expand contraction joints, construction joints. So even in your industrial floors, RCC pavements, this is a standard practice to provide this. So don't try to generalize the detailing, just try to see at what location it has been provided, and depending on that, you need to understand or the reinforcement detailing will be provided. But the concept remains that shear transfers are allowed, but moment transfer should not happen. So therefore, to maintain that discontinuity, uh, as you said, the top reinforcement is not getting continued. So that what I can see is one of the reasons for it. Okay. Next question is from engineer Arbaz Kazi from Mumbai. He is a working professional and he is asking what are slip critical connections? How are they different from normal connections? So see, normal connections are mostly bearing type. Normal connections are called as bearing type, where the load transfer takes place through bearing between your bolts and plates. So, for example, if these are two plates and if this is a bolt, okay, this is my bolt. So, what will happen that I will have to make a hole in the plate. So, my hole in the plate will be slightly larger, of course, just to accommodate the bolt into it. But now what will happen that how the load transfer is taking place. So let's say when I apply a certain load on this, how is the load transfer going to take place? So load transfer is going to take place through bearing action. That means there will be bearing on this surface, plate will bear on the bolt, then there will be shear generated in this bolt, and then the orange color plate will bear on this side. So this is my bearing surface. There is a shearing effect created in the bolt cross section, and then there is a bearing surface over here again. So this is how the load transfer takes place in a normal bearing type connection. So most of the connections that you see are bearing type. Now because this is a bearing type action, and because for workmanship I should say, my whole dia is slightly larger than the bolt dia. By how much amount? Usually the whole dia is larger than bolt dia. Anyone in the live audience knows it? How much larger is my whole dia than the bolt dia? No one knows. So you could refer to the codes, IS 800 or whichever code you are following, AISC, Euro code, whatever you are following, there are values given to you. Generally, it is about 1.5 mm to 2 mm larger than the bolt dia. So now what happens, because it's a bearing type action, what will happen that when I apply this load, there will be a slight slip in the system. Yes or no? There will be a slight slip in the system. Why there will be a slight slip in the system? Because my whole dia was slightly larger than the bolt dia, and now when I'm applying the loads, the action is through bearing. So first there will be a slight slip in the plate, pink plate, then it will begin to bear, on the bolt. Similarly, this orange plate will also slightly slip, right? So this is called as, so there will be a slight slippage. Now this slippage is okay as long as we have a static load. Static load means where the load is always in one direction, acting in one direction. So there will be slip only for one time, then there will be no further slip. But imagine if my load is a dynamic load, or it's a load where the direction is continuously changing. So now what will happen? Hello. Now what will happen? If my load is such that it is continuously changing its direction, what will happen? So there will be continuous slippage. Yes or no? There will be a continuous movement of the connection. I'm not writing movement. I'm writing continuous movement in the connection. Right? Now with this continuous movement, what will happen? If it's continuously slipping, with every load direction change, there is a slip. What will happen? There is a movement, continuous movement, and that leads to fatigue. Okay, repeated, let's say over hundreds of thousands of cycles of this load change, there will be fatigue in the connection. So now if that has to be avoided, what you do is, for such connections where you cannot have such slippages, what you instead do, that instead of having a bearing type of connection, you try to add certain pre-tension in the bolt. Adding pre-tension in the bolt means that instead of bolt transferring through bearing, I will apply certain pre-tension in the bolt. When I apply certain pre-tension in the bolt, what happens? That these two plates are pushed towards each other, correct? When these two plates are pushed towards each other, what will happen? That there is a friction that is generated. So there is a friction force developed between these two plates. Yes or no? Now when there is a friction force developed between these two plates, now how the load transfer will take place? Suppose I was applying this load P. How will this P load get transferred now? So it won't get transferred through bearing, rather it will now get transferred through the friction between these two plates. You understand? So now in this case, even if my hole dia is slightly larger than the bolt dia, because the action was through friction transfer, or because the resistance was being provided through friction transfer, now there will be no slippage. Are you clear? No slippage in the connection. So even for those types of loads where there is a continuous direction change, even for those loads, now you will not have any slippage in the connection. So under such loads, which are continuously changing their directions, because there is no slippage or there is no movement in the connection, with hundreds of thousands of such cycles, there is less fatigue that is generated. So we provide, and these are called as slip critical connections, where we do not want any slippages. And because we don't want any slippages, we will have pre-tensioned bolts used, and the load transfer now, instead of bearing, it is a friction type load transfer. So these are called as slip critical connections. I hope that answers your query. Okay. Now, usually these slip critical connections, we don't provide it everywhere, because number one, it requires a very good skilled labor to do this, because number one, you have to pre-tension the bolt. So by how much amount you need to pre-tension the bolt, so you need a torque wrench for it, and then calibrated torque has to be applied to the bolt. Plus you have to prepare these surfaces for friction type. So that also requires better workmanship. So uh, due to these two reasons, you don't, in general connections, you don't see a slip critical or friction grip bolts being provided. So only for some specific requirements we go for these slip critical or friction grip bolts. Otherwise, Normal connections will be all bearing type connections. Understood? Okay. Next question is from engineer Vinay RB. He is joining us from Bengaluru. He is also a working professional. And what his question is, how to model inclined slab in ETABS, design procedure, how detailing is done for inclined slabs. So see, modeling inclined slabs is slightly difficult in ETABS. ETABS does not support it quite well. So you will not be able to model it using the plan options. Okay, in plan options it won't work. So modeling in plan will not work for you. So you will have to model it in 3D. That means you turn on the 3D view, you make the grid points, or you make the grid layout, coordinate layout you can finalize through grids. So make that grid layout, and then in a 3D view you'll have to model your inclined slabs. So whatever, let's say you prepare this three-dimensional, you have the story levels and grid created. I'm just drawing, this is my grid system in 3D. Now, if you want to model a 3D slab, you will have to use that manual option and then click on these nodes wherever you want to model a slab. You'll have to do it manually. Using plan options won't work. Are you getting my point? So click wherever you want to in three-dimensional grid system. You need to keep on clicking and then model the slab. Okay. So modeling will be that manner. Design procedure remains the same. Once you do the loading, you apply the load. So now the loads need to be applied. That also is slightly tricky. There is an option to apply the load in the gravity direction. If you want to apply the loads in the local axis, that option is also there. So either you apply the loads uh, in gravity direction, or if it's a case of wind load or whatever, you could apply it using the local axis coordinate system of your slab elements. Once you apply the loads, you take the moments, normal moments, M11, M22, M33. M33 does not have any meaning. M11, M22 moments you take, and then you do the reinforcement calculations. For detailing, usually uh, the same procedure is adopted as we do for normal slabs, but you have to be careful at corners where two inclined slabs are joining each other at crown locations, okay, or at locations at the trough locations. So you need to be slightly careful at the corners. So what I will suggest is go through SP34, where they have given some uh, best practices to be followed in case of these corner detailings in for an inclined slab. Now, if this inclined slab is resting on some beam, then at that location again, you will have to see how to provide the reinforcement detailing, and especially if it's applying some thrust, you have to be careful with this junction. So it depends on your assumptions. What is the assumption you have made for this beam inclined slab joint, and also if it's a case of thrust, you need to see their reinforcements are properly developed. So all those things, for this you could also refer to the staircase type of detailing that is given in SP34. Staircase detailing diagrams that are given especially for folded plate staircases, sorry, especially for base slab staircases, you could refer the detailing practices. So go to SP34 for it. Okay. Modeling, as I just told you, it will not work in plan view. Go to 3D view, and manually clicking all the points, you will have to uh, make your slab. Apply the load, take the moments, find out the reinforcement. Open to sky portion or cutout of hall, how the reinforcement is to be given around this open portion. Regarding this opening in the cutout, I could also see one more question by engineer Padma Vijayan PV. Can we make a slab cutout, and what suggestion can we offer? I have a question about installing a hydraulic lift in an existing G plus 1 residential building with a 13 feet by 13 feet room. they are making, they are asking for suggestions on making a small cutout. So I'll just answer the good practices to be followed for slab cutouts. So this will, I hope it will answer question by engineer Vinay also and engineer Padma Vijayan also. So best practices when you have a slab cutout are that wherever there is a slab cutout, especially if that cutout is large, you need to see if the load path is getting disrupted or not. Okay, so what you should do is for large cutouts, you should model those cutouts in your software. For small cutouts, what do I mean by small and large? I would say that if it is more than one tenth of this dimension, if it is more than one tenth of this dimension, try to model that cutout in your software. Otherwise, you could leave it. But if it is more than one tenth, you try to model this in your software. Okay. So you need to ensure continuity of load path. So best way to do that is to have some beam elements added over here. These beam elements will be sort of concealed beam elements within the slab thickness. See, if the cutout is large, then first suggestion would be to have a beam, actual beam. So this beam, actual beam, will help you to support this slab, and support these slabs also. Okay. So for large openings which are going to be loaded, this is the best way to do it. If you don't have uh, large openings, or if you don't have openings which are going to be loaded, then you could have these types of concealed beams provided, where these concealed beams are generally, they have reinforcements at top and bottom both. You could refer to SP34, and then you could just continue the reinforcement of these till LD, and also you provide diagonal 3 bars at top, 3 bars at bottom, diagonal bars, and continue it till LD like this. Okay, so this can be a typical reinforcement arrangement provided in the vicinity of openings. As I told you, if the opening is large, if it is going to be loaded, then it is better to have an actual beam. But if not, then you could have this kind of a detail. Okay, right. So I think this answers engineer Padma Vijayan's question also. He had a question about installing a hydraulic lift in an existing G+1 residential building with a 13 feet by 13 feet room. See, in your case, the cutout will be larger, because in a 13 feet by 13 feet room, hydraulic lift cutout will be, I guess, at least 5 feet by 5 feet. So it's a large cutout that is going to come. So in this case, I'll suggest you to have actual beams provided. Maybe provide a steel girder to support the slab. So have a steel I beams provided. Okay, because your opening size will be pretty large. I would say at least 5 feet by 5 feet in a 13 feet by 13 feet room. So proportionate to the room size, opening is quite large. So better to have an actual girder. Because it's an existing structure, you could have a steel girder or a steel I-beam provided, and try to support this opening like this. So this would be my suggestion. Yes, it could be done. It's a it's a practice that is usually adopted. Mr. Padmajan is saying small cutout in the corner of the room in existing building. No, it's not a small cutout. In a 13 feet by 13 feet room, it's a 5 feet by 5 feet cutout. It's not, I don't think it's a small cutout. If you have to pass a complete lift through that cutout, 5 feet by 5 feet, I think, is the minimum size that you will have for the cutout. So it's not a small cutout. So if it's in the corner, as you're saying, try to have a girder system. If it's in the corner, let's say 13 feet by 13 feet, and a corner, as I just told you. So assuming there are beams over here, try to have a girder which just rests on this beam, maybe like this. Try to have an actual I beam provided like this. Okay, right. So these were a couple of questions asked regarding the regarding slab cutouts. Now next question is from engineer Madan Chandra Maurya. He's from Lucknow and he is an independent consultant. So he's saying, and he has shared one image. So on WhatsApp, he has shared one image. So let me put that image also over here. Right. So the question is, in an existing RCC school building, currently 6 feet cantilever beam is there in the porch, and now the client wants to extend the cantilever beam by 20 feet. I think this he is talking about, that this cantilever 6 feet, the projection which will be G+1 floor will be used as large hall, and above this means on the first floor it will be used as library. The dimension of beam is 230 mm by 600 mm. Total four cantilever beams are there resting on four columns. So I think this one, two, three, four maybe, and these are those beams. Overall, the projected slab will be 26 feet by 56 feet. Kindly discuss it by highlighting any major point which needs more emphasis. And my one line answer will be don't do it. Okay, don't do such a thing, because existing 6 feet cantilever, if I have understood the question and the image correctly, you want to extend it to you want to extend it by 20 feet to 26 feet now. I won't recommend you to do that. Don't do it, will be my one line answer. Because number one, the cantilever, if you extend it, see, if right now this is the situation, let's say, and you had columns, maybe these were your building, and your building was extending over here. So you had columns over here, and you had these beams. This is the plan view I'm showing you, and this was, I guess, 56 feet earlier. This was 6 feet, and these beam sizes were whatever 230 by something. Now you are saying you want to extend it to 26 feet. So this entire thing becomes 26 feet now. So, and you still want it as a cantilever. So I won't suggest you to do such thing. Number one, whatever you do with this beam, your column will not be able to handle a 26 feet cantilever, which was designed to resist a 6 feet cantilever. And plus, as you are saying, it will have a library, so it will have a decent amount of load also. So don't do it. Just say no, it's not possible. Okay. It will be better in these cases to not go for cantilever, but to then have some new columns added, and then right from footing level you will have to make those changes. Okay. Okay. Can we go for a propped beam? Yeah, propped beam means you will have to add a column, right? That's what I'm saying. You will have to add additional columns, but then the existing columns also will need to be checked. Existing footings will need to be checked. It is better to forget about cantilevers, and maybe in this zone, in the 20 feet additional zone, just create new columns and have new footings for it. It is, I will suggest you not to stress the old structure, 6 feet, which adds a 6 feet cantilever. Leave it as it is. Create a new system over here, separate like this. Have 20 feet spacing columns and create a new framing over here. Right? Okay. Then the next question was from engineer Idul, he is saying I am working on my academic project and considering the topic analysis of irregular buildings with what he is saying. Let me just copy. Uh, I am working. Let me just copy his question. So, Mr. Idul from Bengaluru, he is pursuing his masters. I am working on my academic project. I am working on my academic project and considering the topic analysis of irregular buildings with shear wall using soil structure interaction. Due to time constraints and being new to soil structure interaction, I wanted your advice. Is this suitable topic for master's level project? I don't know. You need to ask your guide or your mentor whether this is within your scope or within your capability. Your mentor or your guide should also be uh, comfortable enough in guiding you for this topic, right? So you also need to consult your guide or mentor for this. My saying or me telling you whether it's a suitable topic or not won't help you. Your guide has to tell you because he or she has to help you finally. Should I simplify or modify the scope? What should I focus on initially to understand and implement? Any resources or tips to manage time and complexity? See, I don't have much experience of working on soil structure interaction, so I won't be able to guide you much on this. My suggestion would be to first go properly through IS 1893, try and understand the basics of earthquake engineering. Maybe you could go through ASCE for further references, chapter 11 and 12. I think ASCE 7 also has a chapter on soil structure interaction. So maybe you could go through that. And whether this is a suitable topic, whether you want to reduce the scope, make it simpler, make it more complex, your guide should be telling you that, not me, because he or she is the person who is responsible for completing your dissertation. You and your guide are responsible. So any tip from my side does not make sense. Okay, right. So these were the questions on the Google form. Now there were few questions on the email, so I'll take them also. This question was from engineer Tosh Agrawal. He is a practicing engineer and from Raipur, and he has shared one image. Let me bring that image. So he has shared one PV image over here. PV image means a detail that is typically followed in industrial sheds. So his questions are: is there only his first question is there only one single top flange required to is there only one single top flange required? No need to break it anywhere in this image. Second question is top end plate of rafter is connected to bottom flange by weld. Top end plate uh, is connected to bottom flange. Web 1 and web 2 are single web members or two web members. Okay, so he's saying, okay, so let's say this is my rafter, this is my column in an industrial shed like this, and now I want to prepare detailing for this. Okay, and let's say I want to have a rigid joint made over here. Now there are different options and possibilities that we have. Number one option is that you provide an end plate over here. I'm just telling you the options first. So what happens in that case, that this becomes one member, okay, and this becomes your another member, and it is connected at this location. So this becomes my end plate connection. This is one option. Second option can be that, as you can see in this image, that they have provided the end plate connection over here. So this is your end plate. Now in this case, what happens, that this is your one member, this becomes your one member. So basically it will be a member like this, okay, and let's say this will be your flanges, this will be your web, and then these are your end plates. Now the question is, what is the question being asked? First question is asking, is there only single top flange required, no need to break it anywhere? Yeah, you could have, see, now what you could do is, you could cut this. So this could be one piece, this could be one flange, this could be another flange plate, this could be web. So let's call it as flange 1, web 1. Now you could just weld it using a groove weld or a fillet weld to this piece. Okay, so let's say this is flange 2, web 2, flange 2. So finally, after welding, this piece becomes an entire one piece because you have welded it. So this becomes your piece 1. Okay, and let's call it as a piece A. So now you fabricate this piece A and transport it to site. Let's say this piece A will have a bottom end plate welded to it over here. So let's call it as the plate 1. Now you have another piece B, which is this piece of column. So this piece of column is piece B. It will have its own flanges, webs, whatever, and it will have another plate P2, okay, welded at its end. And then you bring on site these two pieces A and B and connect it through bolting. So this is one of the options possible. Okay, so in this case, this is what they have done. Now several other alternatives that could be, that depends on the fabrication team and their ease of working. If they have the sufficient lengths available, they could also cut this web into one piece, or they could have a single web piece created. So they could have one web piece made by cutting, okay, and this could be one flange piece, this could be one flange. Let me just try to use another yeah, so this could be one flange piece, this could be another flange piece, and a second flange piece over here. So this is what they could do, or as I just told you, they could also have separate pieces, separate pieces, just as I was just explaining you, flange 1, web 1, weld it to this flange 2, web 2, flange 2, have a member A, and then connect it to member B. So all these options depend on the fabrication team. We should be okay with any of the alternatives that they are going ahead with, as long as the required strength is achieved. So there cannot be one answer for this. It depends on the ease of the fabrication team. Uh, yeah, it depends on the ease of fabrication team. Okay. All right. Then let me see other questions. So this was Engineer Tosh Agrawal with his question. Let's see what else we have. What else do we have? Now, so we have taken all the questions on the Google form, and we have also taken all the questions in the email. So I think now we can just have a look at the live chats, live comments, and try and see. if any question has been asked over there. So engineer Padma Vijayan's question we have seen answered. Engineer Aftab is asking, I have a doubt about effective lengths. How will the torsional effective length be reduced when beam to web column connection is provided at mid column height? Flanges of column can rotate freely. Yeah, that's right. So that what you are saying is actually given in the AISC code. Uh, so what AISC code is telling that, let's say I have a column, I'm trying to draw an elevation, okay, and it is integrally connected with beam over here. Okay, you want it in another manner, right? Let me just delete this. You are saying that beam is connected to web. So he's saying something like this, and he's saying that I have a beam connected to web. So in plan view, this is my beam, this is my column. Now, how this beam is providing shear, this beam is transferring shear forces. Now he's asking that whether this will provide you torsional resistance or not. Okay. So strictly speaking, if you have not made any arrangements to restrict the torsional twisting, generally this kind of connection, even though it's a beam to column web connection, still this type of connection can be uh, idealized as providing torsional restraint also, because when it tries to torsionally twist, because of the resistance that is provided, it will still help you to resist the torsion. But if that is not the scenario, then uh, in such cases you could assume that they are providing compression or flexural buckling about the YY axis, but this beam, then you have to assume that it does not provide you any torsional restraint. Okay, so torsional buckling is not restrained. Flexural buckling about YY axis in such cases may be restrained. Therefore, if you see that generally wherever we provide these beam column connections, we have some other systems also, like sometimes we provide these flange braces, okay, or sometimes our cleats that we provide, those also provide resistance against torsional twisting of this column. So I would not say that this type of an effect is seen in a beam to column shear connection, but in connections where you have bracings over there, this type of problem may be seen, where you have a bracing connected to a column, because those connections happen through a single fin plate or a very flexible connection. So over there this problem is seen, and AISC, if you see AISC 360, it tries to address this issue and tells you that if you have bracing systems, they may not be able to provide you torsional restraint. They may, however, provide you restraint against flexural buckling, but they may not provide you torsional restraint. So this statement is there in the AISC 360 if you see, and accordingly then you have to take higher lengths for torsional buckling. For flexural buckling, you could uh, consider the effects of bracings framing into the column, but for torsional twistings, you may not take the effect of bracing. But generally, it will not happen with a beam column shear connection, because there are cleats and there are other elements which don't allow your column to rotate freely as such. Okay, good. But you have made a very good point. You may be interested in reading the commentary of AISC 360 chapter that covers compression. So read the commentary. There you will see some cases given to you. Compression chapter. I think compression is covered in chapter E, I think. So you go through the commentary of chapter E. You will be interested in reading that commentary. Okay, right. I should point out over here that such a distinction between the flexural buckling and torsional buckling is not made for is not made in Indian standard. So this type of distinction is there in the American code, but it's not there in the Indian standard. All right. So I think these were the questions that we had. So we have answered the questions on the Google form and on the live comments and also from email. So I think that's it we have for this week. Thanks. And now we will see you next week. Okay. So bye bye. Take care. And we shall see you now next week. Bye bye. Thanks for joining.